Hello, 7th graders. This is Mrs. Trombley coming with lesson 7.6, surface areas and volumes of similar solids. If you're following along on your book, we are on pages 332 and 333. Please make sure you have your notes, calculator, something to write with. Those are all good things to have. All right, so solids of the same type that have proportional corresponding linear measures are similar solids. That's quite a mouthful. First of all, solids, we're just talking about the 3D shapes that we have been dealing with in Unit 6 and in Unit 7. When we talk about proportional corresponding linear measures, okay, you learned about proportional relationships a while back. We're going to apply those same concepts today. Corresponding linear measures just means the straight lines that match up. So straight lines on a 3D shape could be radius, could be diameter, could be the height, could be slant height. So any straight line that corresponds to the other shape, that's what we're looking for. So part 1 of this lesson is, can you identify similar solids? We've identified similar 2D shapes. Now we're going to try to identify similar 3D shapes. So the question is, are cylinders B and C similar to cylinder A? Check to see if the corresponding linear measures are proportional. So there are a few different ways you could do this. I'm just going to focus on one way. I find that if I show you several at one time, it gets kind of confusing. So maybe we'll explore some other comparisons in class, but for now, we'll just do it this way. All right, so here's cylinder A. I want to know if cylinder A and cylinder B are proportional. They're proportional if their corresponding sides are proportional. So right here, this 6 meters, this matches up with 5 meters on cylinder B. They're both the radius. So here's cylinder A, the radius, and cylinder B, the radius. All right, here is cylinder A's height. Here is cylinder B's height. So if you notice, cylinder A, both on the top. Cylinder B, both on the bottom. The 6 and the 5 both represent the radius. The 4 and the 3 both represent the height. So that's just one way to set it up. Now, if you recall, one way to figure out if these are proportional is to see if their cross products are the same. So let's see. 6 times 3 is 18. 5 times 4 is 20. Nope, those don't equal one another. Those are not proportional. So cylinder A and B are not proportional. Let's try cylinder A and cylinder C. All right, so again, cylinder A's radius is 6. Cylinder C radius is 7.5. Cylinder A's height is 4. Cylinder C's height is 5. Let's find some cross products again here. All right, 6 times 5, that is 30. 7.5 times 4, try that one out. Hopefully you got 30. That's right. So that means that cylinder A and cylinder C are proportional because their corresponding linear measures are similar. All right, next step, we are going to try to find missing measures now in similar solids. Now you've done this again with 2D shapes. Now we're going to apply it to 3D shapes. We're going to use a proportion just like we used in example 1 with figuring out if they were similar or not. So here are 2 cones. We want to know what the slant height of this bottom cone is, assuming that they are both similar to one another. And it says it, the cones are similar. So, here we go. This 13 is the slant height. That corresponds with this slant height. So I'm going to put 13 over L. So these are both slant height. This is the top, this is the bottom. Now again, since 13 came from this one, I want the 5 to come from this one so that the 13 and the 5 are both from the same shape. This 5 corresponds with this 7. So now it's our job to figure out what L is, what the slant height is. Hopefully you're thinking, oh, I did a million of these in skill packets before. All you need to do is cross multiply to make a one-step and solve it. That's right. So 5 times L is 5L. And 13 times 7, type it in, or do it the long way, that's always fun. You should get 91. We're not done because L is not by itself. L is being multiplied by 5, so to undo this multiplication, we're going to divide by 5, and whatever you do to this side, you need to do to that side as well. So 91 divided by 5, that should give us 18.2, and it looks like all of these other measurements are in yards, so 18.2 yards is the slant height of this shape. So basically, when you want to know a missing portion, all you do is set up a proportion, cross multiply to make a one-step, and solve it. All right. Next topic here. If two solids are similar, then the ratio of their surface areas is equal to the square of the ratio of their corresponding linear measures. Again, kind of a mouthful, but basically what this is saying is that if I have two similar shapes, the ratios of their surface areas is equal to the ratio of some corresponding lines squared. So let's do an example with this. So I showed you two solids here as well. This just means that if you know the surface area of this, that's equal to a squared over b squared. All right, let's try one. Finding surface area. The pyramids are similar. What is the surface area of pyramid A? So here's pyramid A. You know that we have a slant height right here of 6 feet, and over here this side length corresponds with that one, that's 10 feet. I tell you the surface area of pyramid B is 600 feet squared. Our job is to find the surface area of pyramid A. So going back to this is going to help us when we set up a proportion, because this is all about setting up proportions to solve here. So it says surface area of A over surface area of B. Let's do that first. Surface area of A, we don't know that. I'm just going to call it X. You could call it Y if you want, but I'm calling it X. So here's the surface area of A. I'm going to put that over top surface area of B, which it says is 600. Up here it says that's equal to the quantity of A over B squared. That quantity of just is a fancy way to say there's parentheses there. So that equals, I'm going to put some parentheses there, A over B squared. So again, the 6 and 10, they just came from those corresponding linear measures. So here are the surface areas, here are the corresponding linear measures. Since we're dealing with area, that's why we need to square it. So before we start solving this guy, we need to get rid of this exponent here. So the x over 600 is good. Over here, I need to square the 6 and square the 10. It's not 12 over 20. Don't put 12 over 20. If I wanted to say 6 times 2, I would say 6 times 2. I wouldn't use a little exponent. 6 squared means 6 times 6, which is 36. 10 squared means 10 times 10, which is 100. Now we have a proportion that we recognize that we can solve. So again, let's cross multiply. X times 100 is 100x. 600 times 36, do you have it? It is 21,600. All right, I want to know what just x is. So x is being multiplied by 100. To undo that, I'm going to divide it by 100. If you do it to one side, you must do it to the other. This means that x is equal to 216, and all of these measurements are in feet. And remember, we're finding surface area, so that means I need to square the unit of measurement. So the surface area of pyramid A, 216 feet squared. All right, flip over your paper. Don't worry, we're not going to do the entire backside here. We're going to talk a little bit about finding volume, and the guided examples we're going to save for tomorrow in class. So no worries. All right. If two solids are similar, then the ratio of their volumes is equal to the cube of the ratio of their corresponding linear measures. Now this makes sense, right? Cube with volume, square with surface area. So this is basically saying the same thing. If you compare the volume of shape A with the volume of shape B, it's equal to the quantity of their corresponding sides divided raised to the third power, or the ratio of their corresponding linear measures is how it's stated. All right, so take a look. These two cones are similar. I ask you to find the volume of solid B. We don't know the volume. Oh, I'm sorry. Find the volume of solid B, it says. I actually want you to find the volume of solid A. I will try to have that fixed before you get these notes home. Okay, so here we go. Following this, it says to take the volume of A over the volume of B. We don't know the volume of A, so I'll call it Y this time. Why, you ask? I don't know. I just feel like it. So there's Y. That's the surface, or sorry, that's the volume of A. The volume of B is 288. up top, it says that we're supposed to set that equal to their linear measures to the third power. So, corresponding linear measures. This 5, that's a straight line, so is this 12. They correspond, and since y is coming from shape A, I want 5 to be on the top so that the a's are on top, and the 12 will go on the bottom. And since we're trying to find volume, that means we need to cube that ratio. Alright, sounds like a game show. Cube that ratio. Okay, or not, whatever. So y over 288 equals, we're going to get rid of this exponent. So 5 to the third power isn't 15, it means 5 times 5 times 5. Got it? It's 125. 12 to the third power means 12 times 12 times 12. That is 1,728. If you don't believe me, check it out with your calculator that I'm sure you have right there that you've been punching in all these numbers as we go. I'm positive you're not just writing down what I write down, right? Humor me. All right, cross multiply it to make it one step. So y times 1,728 is 1,728y. 288 times 125 is 36,000. All right, to get rid of this 1,728 that's being multiplied by y, I need to divide by it. And whatever you do to one side, you have to do to the other. That means that y is equal to 20 and you'll notice that the 3 keeps going over and over and over again. When that happens, we put a hat on it. And these are centimeters, and since we're finding volume, we will cube them. All right, we will save the guided examples for class tomorrow. Enjoy the rest of your evening. Thanks for doing your math homework.